The topic of today's lesson is distributive property, and not so much what distributive property is, but when is it that we use it and how do we apply it to solving mathematical word problems. For example, I am on page 33 of our textbook. Brianna has 6 scenic postcards and 4 animal postcards from each of the 8 places that she has visited. So let's label this. These can be 8. 6 scenic scenes and animals, and these are all the cards that have animals, and these are all the cards from each of the 8 places that contain probably nature scenes. Find the total number of the postcards. So we can think of it in one way. We can say, well, for each place Brianna has 6 scenic cards and 4 animal cards, which is 10 in total. Or we can also think of it she can think 6 scenic cards from 8 places and 4 animal cards. So these are all cards with animals. And these are all the cards with nature scenes. In any case, whether it's 10 cards per place, which is 80 total, or 6 times 8, which is 48. We use our order of operations plus 24. So sorry. 24, Miss Natasha. 4 times 8 is 32. In any case, the total number of cards that Brianna collected from her travels will be 80. So what we see here is the wonderful use of the distributive property. 8 times 6 and 8 times 4 is the same way as to write 6 times 8, 8 times 6, or 8 times 4, where 8 here is a common factor for both scenes and animals. Okay, so let's look at more examples. Is the value of A and B the same? Use the model to explain. We're not going to draw the model. However, what we're going to do is the difference of 10 and 4 multiplied times 3. Okay, well, the difference of 10 and 4 is 6 multiplied times 3 gives us 18. We can also look at it from a different point of view. We can say, well, 10 taken 3 times is 30 minus 12 gives us 18. Whichever way we look at it, we get the same result. Why does it work like this? Well, 3 is a common factor for the difference of 10 and 4. We can say 3 taken 10 times minus 3 taken 4 times. Let's look at it one more time. Let's look at more examples of distributive property. Number 16, find missing numbers. 20 and 5 taken 3 times is the same as 20 taken 5 times. So sorry. One more time. 20 and 5 taken 3 times is the same as 20 taken 3 times and 5 taken 3 times. I look at it like this. 3 is a common factor for 20 and 5, and we can look at it like that. We distribute the common factor to both, to 20 and 5. Let's take a look at B. The difference of 50 and 70 is taken 8 times. We can think that 8 is the common factor for 50 and 7, which means 50 taken, let me pick up a different color, 50 taken 8 times minus 7 taken 8 times. Take a look at example C. 7 times the sum of 4 and 3. 7 here is a common factor for 4 and 3. 7 times 4, different color, 7 times 4 and 7 times 3. Take a look at one more example, D. 3 is a common factor for the difference of 12 and 2. Well, the difference of 12 and 2 is 10. It's the same as we take 12 3 times minus 2, or 2 3 times. Take a look at example E. Here the problem in E and F, I'm going to draw a very thin line. In E and F, we have a slightly different problem. And the problem is the following. We have 3 taken 4 times and 3 taken 5 times. What is the common factor? Of course, we multiply 3, both 4 and 5 times. The total, we take 3 9 times. We took 3 9 times. Take a look at example F. We have a difference. 10 times 72 minus 10 times 28. We have 10 is a common factor. So we can say we took 10 72 times, but then we subtracted 28 tens. Or we can look at it this way. Now, again, more fine missing number exercises. And I'm only going to focus on the bottom 4 while you guys can do ABC on your own, the bottom 3. So let's take a look at the bottom 3. Let's read this again using algebra language. 70 minus 1 times 4, which is like we take 4 69 times altogether. So we can say that yes, 4 is a common factor and we can distribute it to what's inside the parentheses. So we take 74 times and then minus 1 extra 70, only 170. 69 times 4, well, we can think of 69 as 70 minus 1. We've done this using mental math. And we can say 70 taken 4 times minus 70 taken 4 times minus 1 extra 4. Here 4 is a common factor. And finally, 99 times 8. We can think of 99 as 100. That's an easy way to represent 99 minus 1. So we can say 8 hundredths minus 1/8 would give us the same answer. Again, we're using the distributive property. Take a look at number 18. We don't need to calculate. We have something on the left and we need to compare it with something on the right using less than, greater, or equal symbols of mathematics. Well, 6 times 5 and 6 times 8. Here we have 6 times 5 and 6 times 6. Of course, we have more 6's on the left. Therefore, we use greater than sign. I'm going to look at number C. Again, let's compare the left with what we have on the right. And again, we have 8 taken 4 times and then 8 taken 3 times. And on the right, we have the same thing. 8 taken 3 times and, meaning plus, 8 taken 4 times. That is equal. So my friends, this is the use of distributive property, and we are going to apply it when we start computing our mental math examples in the future chapter.